Okay, so, just kidding. This is the example we ended on yesterday. It works out perfectly, it works out evenly, which means x plus 5 is a factor of x cubed plus 125. And more specifically, I can actually write x cubed plus 125 all over x plus 5 as x squared minus 5x plus 25 times x plus 5 over x plus 5. But why? From this one division problem, how can I jump there? I'm factoring, but how am I using the division to help me know how to factor? What went into this?
Oh, the x plus 5.
And how many times did x plus 5 go into x cubed plus 125? This many, right? So if x cubed plus 125 divided by x plus 5 is x squared minus 5x plus 25. That means these two multiplied together, if we were to do the nasty distribution, right, we have to distribute everything to everything, it would end up right back here. Which is why you can see another way that we can say this division just equals the x squared minus 5x plus 25. So yes, this is helpful in division problems and simplifying, but it's also helpful for finding factors, because factors are expressions that divide evenly into a polynomial, which means with a remainder of 0. Does that make sense? If the remainder was anything else, would it be a factor? No. Is the division still right? Probably. But only if the remainder is 0 is it a true factor. Now, do we actually have to use this division algorithm for this one? No. Why? Did we have a remainder? But if we do have a remainder, so if you guys are labeling things, this would be the quotient, this would be like the whole expression, this would be the remainder, this would be the little part that's left over. Ugh, if I can get remainder. We could technically call this like the divisor if we wanted to be really snazzy. And this could be like our, well, it's our function that we're dividing into. Huh?
The line from the f of x function is perfect.
You're a goof. So, when we're dividing, we could write it quotient plus remainder, but that's awkward. We don't want to write it that way, so how are we going to write it instead? Q is a whole thing plus remainder over divisor. And that's what we did yesterday, right? Because when we had over here, when we had a remainder of 39, we wrote remainder over divisor, and that was our fractional piece. So that's what that little algorithm is for, just to let you know if you do have a remainder, here's the proper way of writing it. We could do that too, but it's kind of, I don't like that one as much. You guys are having way too much fun. Okay, let's go ahead and keep going then. We did long division yesterday. What did we not do? Why is there so much writing? Because you guys know what this is. You just have to remember. So, let's see if by writing we can remember how to do synthetic. It's a shortcut. That only works when you're dividing by x to the first power, sadly.
So sad.
I know, it's a struggle. Yes. Here, that's my desk for a second. Oh. Is that the So synthetic division, great shortcut. you guys are writing, it can only be used when you're dividing by an x minus a, or something that can be rewritten in the form of x minus a. And then steps. This is the reminder of, I almost said remainder, the reminder of how it works. Take the polynomial's coefficients of each term, and if a term is missing, make it 0. Plug in x equals a to the box. Why I have this over to the side is just to remind you. X equals a is the solution of the factor. And x minus a is the factor itself. Just so that we have these distinguished, so we know the difference between them. X equals a is the solution of a certain factor, and x minus a is the actual factor itself. That doesn't look like factor. I don't know what it looks like, but not factor. There we go. So we plug x equal to a in the box, which is the solution. You always carry down the first coefficient, and then you follow the multiply add pattern, which we'll see as soon as we embark on this next example on the next page. So if you guys want, you can write down the example, and then we'll go ahead and solve it with synthetic. But could you solve it with long division if you so desired? Yeah, of course. Who would go in the box? The first one. Who would go outside? The second one. But since it is of the form x minus a, we can use the shortcut, so I guess we'll review. I'm going to go ahead and dual page it just because we don't need that much room for the example on the next page. If some of you are still writing, you can still see what's going on. Okay. So who goes in the box?
3.
Three, just three.
It's
Positive 3. ¿Por qué?
Whoa.
because it's x equals a, not x equals negative a.
X equals a, not negative a. Pretend like you were finding the 0. So to equal to 0, find the solution this gives us, which is 3. Now we don't know if it's an actual solution or an actual 0 unless it goes in evenly, but it's our hypothesized one. It's the one that we think possibly will be. Steal the coefficients, 6 and 7 and negative 1 and 26. Why no zeros? Because every single term was there, right? So we've done number 1, steal the coefficients. Number 2, plug the x equals a into the box. Carry who?
The first coefficient.
Does that make sense? Carry the first coefficient, carry it down. What's the multiply add pattern?
6 times 3.
And then add. We got it? 3 times 25 is 75. Minus 1 is 74. 3 times 74 is...
So,
It's not going in evenly, but if we're supposed to be dividing, we have to finish. So it's going to be 3 times 4 is 12. Carry the 1. 21 plus 1 is 22. Lots of 2's. Add that puppy. 6 and 2 is 8. 2 and 2 is 4. Why did I draw a line?
because that's your remainder.
There were 4 terms to begin with. Cubic, quadratic, single x constant. As soon as we divide, there are only 3 remaining. Anything extra is the remainder. Good. So how would I write this as an answer in the proper way, using that algorithm?
6 squared plus 25x plus 74 plus 248
Over.
Minus 3.
x minus 3.
Does that make sense?
Yes, ma'am.
Algebra. What? Killer.
Synthetic division is not really useful if you have like 2x plus 5, right?
Well,
you can use it.
could it be?
Yeah.
Yeah. How could we rewrite 2x plus 5 into the form x minus, was it 2x plus 5? Into the form x minus who?
X minus 2. And well,
Who would your A be? How do we find A? Times 0. So then x equals negative 5 halves. Who's A? Negative 5. They mean the same thing.
Yeah, but
So then we
for synthetic
could.
division, you can use it, but it just makes it like,
Oh yeah, it's not going to be fun.
yeah,
I would do long division.
yeah.
But you could. I was just showing you. You just have to use the 5 halves instead of the 2x plus 5. Shh. Be nice. Oh, we have something else. We're going to use synthetic again in just a second, but there's one quick reminder first. Applications. Wait, already? Yeah. Can't practice them all day long. But you guys did great. Applications of synthetic division. Now this one is kind of a big one. Whatever the remainder, but it's a nice thing. Whatever the remainder is after performing synthetic division, sounds like surgery, after performing synthetic division, is the same thing as the function value at A. And to find the function value at A, you would have to plug in A and simplify. And plugging in is sometimes easy, right? But it's sometimes kind of hard too. To find R, all you have to do is perform what? Synthetic division. Which maybe we'll have easier math to do than plugging in. Hence why this application is kind of cool. Because maybe if you did need to find a function value, it'd be easier to find the remainder from synthetic than to plug in the nastiness. And then from this application, if the function value at A is 0, what does that mean as far as who else is 0? The remainder must be 0. And if the remainder is 0, isn't that a good thing?
Yep.
That means x minus A is a factor because it goes in evenly. And similarly, we could also say x equals A is, I could say solution, but I'll say is a 0. Is an x-intercept. So just stuff that we can pull out. And the nice thing is I'm not going to leave this totally ambiguous and like whatever, lots of words, what's it mean? Let's go ahead and do an example with it. Let's make this example fun, because right now it's kind of lame. Meaning, we'll still do A, but we'll do another one also. Let's also do don't need that much room, do we? Let me do it again. Okay. Question, how hard is it to plug 1 into that function?
Not really.
Too bad, right? I could say f of 1 is equal to 2 times 1 is 2, minus 7 times 1 is 7, plus 3. We could plug in real fast and get what? 5 minus 7? Negative 2. But that's not using our application of synthetic division. So hold on, we'll come back to this. We plugged in 1. But let's do synthetic division with, wait, how do we do synthetic division? It just says f of 1, who goes in the box. 1. 1 is my A. So I'm going to plug 1 in my box. I'm going to steal the coefficients, right? So I have 2, I have 0, I have negative 7, and I have 3. Is that good?
Mm-hmm.
Where'd the 0
Oh yeah,
That's
that's weird.
sad. Where'd the 0 come from?
That wasn't sassy, it was just dumb.
Maybe not sass.
No, I was like, I was thinking like, I don't get why. It wasn't sassy, come on.
Come on.
Y'all are rude.
Okay, let's do synthetic division. Carry the
2.
I'm pretty sure you got this all done, yeah?
Yeah.
Yeah.
I mean, I wish every problem was like.
So what does that -2 signify?
That's the
Remainder.
The remainder. Which means, well, let's do one more example before I say which means. And go ahead, just because this is going to get confusing pretty fast. Just flow down the line. Letter B. Let's plug in 6. Yay, this sounds fun. So 2 times 6 cubed minus 7 times 6 plus 3. Let's not. Let's do synthetic division. Not saying it's impossible, but I know some of you started to freak out as soon as I said 6 cubed. So, synthetic division says put 6 in the box. Okay. And then take your 2 and your 0 and your -7 and your 3, and you guys get ahead of me. Do that synthetic. Maybe you go fast. Just make sure you go carefully. Kind of like when you drive. Hopefully.
Not definitely not Christmas.
Joke.
Kristen's a sleepover.
Oh, I have to multiply 65 times 6?
That's not bad.
That's
Let's
okay.
go,
It's
let's
maybe
go.
better than that. So, 6 times 5 is 0, carry the 3. 6 and 6 is 36, plus 3 is 39. Huh. Guess what?
It's a weird remainder.
Hey, I didn't have to do that crazy math up there.
Wow.
Now, some of you are like, that would have been easier. Okay, fine. A lot of you are like, well, that means that they have really good mental math skills, and I want to say good job. But this might be easier for some of you. Yeah?
Yes. Big.
Now, hold on. So what does this all mean? First of all, do x minus 1 or x minus 6 go into this function evenly?
No.
No. Why?
It's not.
Plugging in the 0, plugging in the 0, or plugging in and doing synthetic with the 0, plugging in and doing synthetic with the 0. Did either of them, and if one is, the other will be, were they equal to 0? No. So let's see, how does this property R equals f of a help us? If we wanted to test all the possible factors that might go into a polynomial, could we plug and see if it's 0? Yeah, but couldn't this be hard sometimes? So what else could we do besides plugging in and seeing if it's 0? We can do synthetic and say, is the remainder 0? Does that make sense? Sometimes plugging in will be faster, so maybe you don't have to do synthetic all the time, but sometimes doing synthetic is faster, so let's do it that way.
Okay.
So not only finding, thank you, Susan. Not only finding function values, which can be helpful, right? Some of you are like, don't want to do that. But then for others of you, and for all of us, I should say, if we need to test factors, we might be using synthetic more than we think. Let's keep going. That's the same thing we just did. Never mind. I guess I gave us more room. How about this one? How then, thinking of all that we just talked about, how then could we use synthetic to show that x equals a is a solution of this equation, hence is a 0? There are 2 different ways. One says plug it in, does it work? And the second, which is what they asked us to do, is synthetic.
All it says is so that the remainder is 0?
Uh-huh.
Okay.
If the remainder is 0, then we can say true, right?
Mm-hmm.
If the remainder is not 0 either, we made a mistake. Or it's not a factor. Who's going in the box?
Which is 2?
Does that make sense? Because it's not x. What does this signify? A factor of x minus 2. But who's the solution? Does that make sense? That's why we have to understand the difference between solutions and factors. Whew. How'd that go? means x equals 2 is a 0, which also means x minus 2 is a factor. And if it's a factor, how can they ask us to factor completely? Because this already shows me one piece of my factor. What can I say? Do you guys remember from that one long division that we did? Move this back over. What can I say this polynomial is? Or what it equals, just from the synthetic division alone?
It's equal to x squared plus 2x minus 3 times the factor that, which is x minus 2.
Do you guys agree?
Mm-hmm.
X minus 2 went in evenly, so I can, in a sense, factor that out and say when I factor that out, when I divide, who's left? And remember, if this is a cube, it always goes down by 1, and we just go ahead and put them in, right? Is that how you guys learned to do something?
Why
It
is it not
says,
divided by x minus 2?
well, we could say that too, if that would help. Ready? Couldn't we change this around and say divided by x minus
Oh, yeah.
2, and what could I do? Multiply it
And factor the top.
to the other side. Does that make sense? So because of the division, we can say that this multiplication is true. Now, hold on, they said factor completely. Can we keep going?
Yes.
Hey, it's a quadratic. What can we do with him?
Let's the orals a dozen.
I love HonorsPrecalc.
Dun, 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 dun. How do we factor?
X plus 3.
No.
Wait. Oh.
Yeah.
Oh.
Plus 3.
Wow. Come on.
Minus 1. Look at you guys blindly following. Good thing Pied Piper's not close. X plus 3 times x minus 1 times x minus 2 fully factored. Dun, 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 dun. Hey, remember in section 2.2 how all of the higher order polynomials were easy to factor because they were greatest common factors? Guess what, in section 2.3, are they going to be as easy anymore? Because we now have what tool to help us? Synthetic. Kristen.
So because it equals 0, that's why we did the whole x squared plus 2x minus 3 and then parentheses. Okay.
Because we could say this one divided by x minus 2 is perfectly him, no extra weird fractions. So then we just move the x minus 2 over and said, oh, hey, they're factors. And then now, so far, have you been given a nasty polynomial, been told to factor, and not been told any clues like x equals 2? Okay, so far they're still kind of babying you a little bit, which is okay, we're working up for things. But it might be coming the time where it says, hey, here's something, go find me factors, and they won't tell you one. Might get a little bit harder past that. But maybe that's not yet. Hold on. No way. Is that it? Who's done?
Yes, way.
We
Jesus,
should
no.
sue.
Yahweh.
No,
we're
Yahweh.
Let's take a step. Take a step back.
Homework.
Let's,
What's up? You want to go? I see you. Something like this.
Okay, hold on. I want an example like what I was just talking about.
But then after that.
But then after that, yeah. Let me go find one from
I see you,
homework-ish
Norma.
exercises. It might be one, it might not be. Oh wait, that's not yet. Hold on, that's still coming. All right. I still want to show you an example, even though it's not coming for a couple sections, because it ties in perfectly to what we're doing. So, let me give you an example. I don't want that marker. That'd be bad. Although I have gotten Sharpie off of this. What if I said the directions? Ready? Last example. Factor the following. F of x equals 2x cubed plus 3x squared minus 8x plus, whoo, no clue.
Living and loving. Wow.
problem. We have nobody to put in a box to test.
Yeah.
Alright, well, does anybody know of any candidates that we could test to see if it goes in the box and if it works?
No.
0!
Oh, wait.
Only true if there was a common X with everybody. Not 0. Anything else we can plug in the box?
1.
1! Alright, now hold on.
1's not anything.
We could start doing 1.
4,084.
Or if 1 is easy to plug in, isn't this the same thing as the remainder? So couldn't we kind of cheat if 1 was easy to plug in and say, hey, does 1 work? 5 plus 3 is 8. It does work. Now why are we still
Okay,
going to
we're
do
such
synthetic?
cheaters.
Why are we still
fact
going to?
check?
Because, well, to fact check, but don't we have to find more factors than just 1?
True that.
So if we do synthetic, then we're breaking it down to something that we can factor.
Sean Durkin is.
I need clinical help.
Alright, so,
How do I feel about that? Stop.
because he's laughing. That's true. Otherwise we shouldn't be laughing. Okay, we're plugging in 1, right? 2, 3, negative 8, 3. Some of you might still be a little lost as to why we're still doing synthetic, but hang in there. We have to factor it as far as possible. You guys gonna get a head start?
Why you always touching Yeah, I see the stop.
Oh, I brought them in November. We should see.
Ooh.
Why did we still do synthetic if our goal was to factor? What did synthetic get us?
Even more factors.
The next piece to work with.
Oh, the next piece.
Right?
Okay, yes.
Right?
Yes.
So now we can say our original function equals, wait, what does the 1 signify again?
The remainder.
X minus
The
1.
remainder was 0, the
Oh.
1 was the solution to who?
Oh, wait. Minus 1.
We can make a factor out of the 1,
Oh.
right? By making x,
Okay.
because the 1 came from. And now we have our 2x squared plus 5x minus 3. If you really don't like factoring, I guess you could do synthetic again.
Minus 6 and plus 1.
Or you could say, wait, let's practice this. 2 times negative 3 is,
6 and 5, 7.
so we have 1 and 6 or 2 and 5, or 2 and 3. Which one makes sense?
1 and
The 1 and
6
the 1
and
and
minus
6 because the
1.
1. because
I
the
need
6
a
could be-
negative. So I need
Yeah.
1 to be negative
Plus
and 1 to be positive. Does that make sense, the difference?
So it would just be x minus 1 and x minus, no.
Careful, remember, we have to do
Oh,
it
yeah.
quickly.
I can do
But we can do our minus x and our plus 6x and our minus 3 and our 2x squared. And then we can do our grouping. Pull out an x. Pull out a, don't forget the plus 3.
Oh, this is 2.
Working?
Working.
So then we end up with x plus 3, 2x minus 1. What can we very easily forget just because we were
Oh,
solving?
the x minus 1 is the other one.
Maybe we shouldn't have stopped writing him? Dun, 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 dun. Nice. Guess what? That's from section 2.5. Pro status. Okay, homework. Do you want to see it and write it in your spirals?
Yes. Yes.
All right, here we go.
No.
You guys did.
Reverse stuff.
Actually, I was studying for a job. I thought it was due to Eric gets this. In biotech.
Now, the crazy thing is, listen. The crazy thing is, technically we were supposed to start section 240 today. But we just peek at 240. We kind of remember us.
Yeah, whoa, whoa.
Now wait, pause.
That's one of the-
Pause.
how to do the calculators.
We're gonna kind of be booking it tomorrow, so you guys can work on homework today. Sound good?
Yeah.
Yeah.
Sounds
Because we have still, what, 7 minutes? 8? Or, if you're not working on homework, I'll just keep going because we got stuff to talk about. But, complex numbers. If they weren't so hot last year, what would be a really good idea? Look at section 2.4 tonight. Look at some of the examples. Come in tomorrow a little bit prepared. If you don't like imaginary
Why
stuff,
do you need to find imaginary numbers if they're imaginary?
huh?
Why do you find imaginary numbers if they're imaginary?
Electricity.
Oh.
What?
Don't you need it for
How do
engineers?
you-
I don't understand.
I'm not gonna
You
be
should
an
research.
engineer.
I might show more. We got this, but I'm just saying, you might look at some examples tonight. Okay, so homework, if you, oh, she's gone today, sorry.
Okay.
We tried. Here you go. Section 2.3, go. You guys want extra books? I have 1, 2, 3, 4.
Oh, dude, you got into your head.
You actually use it.
Of course I do.
I never just like
Hold your arm, dude.
I don't comprehend.
Yeah, I know you have Sean.
Yeah.
Sorry, not everybody. No.
I like it.
What? What?
We can get at least one book per group we can share around.
Like having like a harvest kind of thing, like each day would be like something different. And it's actually a very good idea what we're gonna do. And we already have fundraising in line for it too, so.
Yeah.
Uh,
Go team.
Okay,
No, this is
okay.
Mika.
Almost right here, so both of us can.
Girl got fried.
She answered me. Rachel, she answered me at 11:30. She's like,
Oh, did you text me?
You today?
I texted her the
Is
morning.
this how you like?
Yes, joined the fourth grade. She asked me one.
No, it would be the